Welcome to this Angular Performance Tuning crash course. In this course, you're going to learn how to performance tune your application in 3 steps. Step number 1, generate a performance profile like you see here on the background to know what parts of your application are taking up the most space in your bundle. Step 2, split up your application into smaller chunks using the latest standalone components lazy loading features of Angular that make it very simple to split up your application into chunks without you having to do a lot of refactoring. Step number 3, use the latest features of Angular 17 to do partial template loading smaller parts of a certain screen only if they are really needed by the user. All of this based on a real-world example of a running software as a service application codebase. Without further ado, let's get started learning Angular performance tuning. Welcome back to the Angular University YouTube channel. Now, the first thing that you need to do, step 1, is generate some sort of a report like this one that you see on the background in order for you to be able to know what parts of your application are taking the most space. This is essential. You shouldn't be flying blind while doing performance optimization. You should always base yourselves on some sort of metrics, some sort of report. And this report that you see here, that you are going to interpret later on in this video, is based using the Source Map Explorer package that you can find here on GitHub and on NPM. So the first thing that we should do is to install this package in your code base, and you need to generate a report. Let's then switch back here to our IDE, and now here in your package.json you need to make sure that you import the Source Map Explorer. So if you check here on my package.json, here it is, the Source Map Explorer. You can install it here in the terminal using npm install and then the name of the package. All right, so once you have the package, you need to generate a report. Here is the command that I use to generate a report. I've called it, let me increase here the font, I have called it bundle report. So this is an npm script. You can see that it's here on the script section, and it's this last script here. So this report works in 2 parts. First, you need to do a production build of your application. So we are going to do an ng build -- configuration production, and you need to generate source maps. Otherwise, this is not going to work. You won't be able to see the performance report. Then, once the bundles are generated in your local file system, and notice that these are uncompressed bundles, these are not the bundles that you're going to be using in production, these have not yet been compressed. So after you have the bundles on your file system, you are going to open the Source Map Explorer report in a browser. All right, and I recommend that you add a similar npm task to your project so that you can easily generate a report anytime that you want. So if you now head over to the terminal, let me increase here a bit the font size, you're going to do npm run bundle-report. And this is going to take a moment, but when it completes, you're going to get a report just like the one you saw. Let's go back to the browser then. Let's learn how to read a bit this report. So your report is of course going to look a lot different than mine. My report is for an application that was already heavily optimized. And let me give you a quick demo of the performance of the application. Let me see, this is one of the live examples. If you are curious, this is from my other company, onlinecoursehost.com. This is an online course platform. And you have here an example of a creator that publishes courses on the platform. You can see that everything is lazy loaded. So you click here on this screen and this screen gets lazy loaded only if the user needs it. The same thing here for the subscription tab, for the admin screens, everything is lazy loaded. So all of this code only gets loaded if needed. The print functionality that we have here to print certificates of completion is only used if the user really needs to generate a PDF. Otherwise, we are not going to load that on the main application bundle. So the application is already split up almost as much as possible, and you can see that there are not only 3 or 4 bundles. You have here tens of bundles that are getting generated. And notice that these sizes, don't get scared, the actual main production bundle is much smaller than this. It's around 500, 600K. This is the uncompressed size of the bundle. But what is important here is this percentage. So our main application bundle, which is this square here, it takes up 22% of our code base, which is actually quite a nice number because the bundle has Angular that takes up 11% of the total. It has Firebase and Angular Fire that take up a lot of space. So this main application bundle is already of a relatively small size compared to the rest of the application. The other bundles that you have here, for example, contain heavy dependencies such as a PDF generating file, PDF make. This is on a separate bundle. We don't want to put all of this code here on the main bundle. Printing PDFs is a functionality that is rarely needed by the user on this particular application. And you can see here all the other bundle sizes that we have here. So as you can see, this application is already very well split up into a large number of bundles, and that's why it feels so fast in production. Now, how do you turn your own Angular application into something like this? Based on this report, you start by creating separate lazy loaded bundles. Going back to your code base, let me show you what is the best, most optimal way of taking a monolithic Angular application that has a huge main bundle and split it up into smaller bundles. Well, I think that the best way that you currently have available in the latest versions of Angular is by using the Angular lazy loading features that come with standalone components. So let me show you how simple it is to take a route of your router and make it lazy loaded using standalone components. So before, if you were used to lazy loading using modules, you would have to create a separate module, then add its dependencies, and then deal with missing dependencies, errors, etc. It was really a pain. And that is why probably most of the times you ended up not using lazy loading. Well, now with standalone components, it's extremely simple to make your whole application lazy loaded. And it's also extremely simple to migrate to standalone components. So if you really want to split up your application into smaller modules, you should first migrate to standalone components. And let me show you here the migration. So you just go to the command line and you're going to run the following command: ng generate Angular core standalone. And this is going to create a 3-step migration that is going to automatically migrate your application to standalone components so that it's easy for you to split it up into lazy loading modules. All right, so I'm not going to go deep into this migration here on this particular video. I think that I will make a separate video about it. If you want to learn more about how to migrate an application to standalone components, you can go here to my blog on the Angular University, and here in this article, Angular Standalone Components Complete Guide, you're going to find here the way to, well, you have here a description of the steps on how to migrate and a few tips on how to perform this migration. Again, I might do a separate video on it, but the bottom line is that once your application is using standalone components, and the migration of this particular code base was very easy to do, it only took a couple of hours, a morning, I would say, and it's a large application. But once that was done, all I had to do to turn this application into a fully lazy loaded standalone application was to go here to these components and switch here component by load component. And all of a sudden, all of the screens of the application became lazy loaded. Let me give you an example. We are going to go here and we're going to run our application here in local environment. So this is now running on my computer. Now let me show you an example of a screen that could benefit from lazy loading. It's the course player screen. So whenever I click in one of the lessons of the course, you're going to be taken to this screen, which is a fairly complex screen that contains here a course player. It contains support for different types of lessons like audio, quizzes, etc. It contains a video player. So it's a relatively heavy component that we would like to separate into a lazy loaded bundle. So how do we do that? We go here to our routing configuration and we identify the route that we want to lazy load. It's this one. And if you notice currently, if I go back here, I refresh here this page and I clear the network cache, I'm going to show you that the screen is not lazy loaded yet. So if I filter here by JavaScript and I click here, for example, on Introduction to Angular, no extra JavaScript was loaded. So this screen here is not being lazy loaded. All right. Now let's go ahead and let's turn this into a lazy loaded screen. I'm going to go ahead and instead of adding here the component property on this route path, I'm going to go ahead and I'm going to add load component. All right. Load component, and let me go ahead and let me add here the code that is going to lazy load the component. So it's something like this. You are going to do a dynamic import of the component itself, and that's it. So you no longer have to create a separate module in order to do lazy loading. Sometimes in certain projects there was even this pattern of creating one lazy loaded module per screen of your application, which could be very cumbersome because you need to import everything each time. With lazy loading component, with standalone components, in order to use lazy loading in a screen, all you have to do is switch component to load component, and that's it. Now that we have made this screen a lazy loaded screen, let's go ahead and let's go back to our application and let's click again on the watch course screen. So I'm going to click here on the video player and notice that this time around, this loaded a bunch of JavaScript, including the watch course lazy loaded bundle that we have just created with load component. So as you can see, if your application is fully converted to standalone components, it's super easy to turn it into a fully lazy loaded application where every single screen is lazy loaded. You just have to go everywhere and replace component by load component in your router configuration, and that's it. Once you complete that process, most of the performance tuning of your application should be completed, and you should see a report similar to this one, where you can see that your main application bundle that you see here only takes up a small percentage of your overall code base, and larger libraries like PDF generating libraries, chart libraries, etc., they have all been moved to separate lazy loaded bundles. Now, when do you know that you have split up your application into enough bundles? Well, the best way is to check here the main bundle. So you click on it and you should see that the vast majority of the bundle itself is comprised of the content here coming from node modules. So you can see that there is very little code of the application itself on the main bundle, just a few components, and we have the services of the application. These are global, and we also have here a few libraries. So the ideal scenario for your main bundle is that most of its content comes from node modules and that you have very little application code in it. You should be able to see Angular in there, and ideally not much more. You should be able to see a few of your components, but that should be it. In the case of our application, we have also Firebase, and we are going to improve this. This is still a lot of JavaScript. We are upgrading this library, Angular Fire, to a newer version that has a tree shakeable API that is going to make it easier to reduce further the size of our main application bundle. But in any case, this is what you should see once you have a well-optimized application. Your main application bundle should have a relatively small percentage of the total size, and it should contain mostly libraries and not much of your application code. Angular should take up a good chunk of your main application bundle. It should be the bigger part. Now, let's go ahead and let's introduce another performance optimization technique, which has to do with doing lazy loading inside a given route. So going back here to our code base, we are already lazy loading this component, right? But this component is a fairly large component. If we go back here to the application, we can see that this component is a course player that supports different types of lessons, audio lessons, digital downloads, assessments, etc. And that is all part of the watch course screen. But imagine that this course only has video lessons. It doesn't have audio lessons, etc. Then loading the code for the audio lesson would be unnecessary and premature. Ideally, we should only load the code for the audio lesson whenever the user clicks on an audio lesson. There should be here some lazy loaded bundle. And that lazy loaded bundle should contain the code for the audio player. Now, it's clear that right now the audio lesson code is not being lazy loaded. So everything is part here of this watch course component. So how can we further split this up? Well, I'm going to go here to the template of watch course, and I'm going to identify the section where we are using the audio lesson code. So this is the audio player component that is going to have the code to play an MP4 in the browser. All right, so we just want to load this code if this condition is true, meaning if the lesson is of type audio. Well, now with Angular 17, we can do that very easily using the new @defer template syntax. So @defer is going to make anything inside the defer block lazy loaded. All right, so this is called partial template loading, and you can pass in here different types of conditions for doing this lazy loading. Now, you should use, if you want a custom condition, you should use the when condition. So I'm going to say that I want to lazy load this bundle only when this condition is true. So now all we have to do is to grab this code here and move it inside the defer block so that the audio player gets lazy loaded. Now, a couple of nice tips. I'm going to use here Angular self-closing tags. And since we are at it, I'm going to refactor this and use the new Angular 17 @if syntax. So this is going to look a lot nicer. So we are going to do @if, and here we are going to add the same condition, and here we are going to add a curly braces block. All right, so now that we have put this in place, let's go ahead and let's go back here to our browser and let's try out the new partial template loading feature. So if I go here through the different types of lessons, there is no lazy loading going on, but notice that now if I click on the audio lesson, all of a sudden we get here the audio player component that is getting loaded, and this is due to the use of the defer block. So if you want to learn more about defer and all its features, you can always check out the official documentation. It's very detailed. I have also created here a guide with examples where I cover this also in detail, and I'm showing here all the different triggers, explaining them step by step. You have built-in triggers, you have custom triggers like the one that I've created. And if you want to check here on YouTube, I have also here on the channel 1, 2, 3, 4 videos on Angular Defer, so you can always go and check them out. Now, going back here to our code base, you might have think when loading or in seeing this that we are repeating this condition, but these conditions here serve different purposes. This condition here tells Angular when to lazy load the bundle, and once the bundle is lazy loaded, then the code is available in the browser to be used. And this condition here tells when to show the audio player, only when the lesson is of type audio. So these are two different things, at defer and at if. Because remember, you might have loaded the audio lesson here in our player, like it's the case here, but then you move to another lesson and you want to hide the audio player again and replace it by the video player. This is why we need this at if syntax here in order to conditionally show or hide the audio player, and we need this extra separate condition to tell Angular when to fetch the code from the backend in the form of a lazy loaded bundle. So in summary, this is how you can do the performance tuning of your Angular application. Step 1, always make sure that you create some sort of a report that allows you to see what is taking up space in your application. Step 2, I recommend that you upgrade to standalone components. It's very easy with the migration, and then just replace component by load component everywhere, and you have an application that is lazy loaded completely, meaning every single screen on your application is going to be lazy loaded. Then you can always run the report again and continue your optimization. If you need to do partial template loading, you can always use at defer. And with this, if you apply these tips, your Angular performance startup time and in general the performance of your application is going to be greatly improved. So I hope that you have enjoyed this Angular performance tuning crash course. If you want to learn more advanced Angular topics, check out my website, the Angular University. You have here many available free lessons. Any lesson here that doesn't have the P as for Pro is free, so you just click on it and you can watch it directly on the website. No login is required to watch the free lessons. You have available here all sorts of courses. You have a deep dive into Angular Core, a TypeScript bootcamp, RxJS, Forms, Router, Reactive Angular Patterns, NGRX, testing, security. You have Angular Material, server-side rendering, and much more. So check out the Angular University. Please leave me a like here in the YouTube channel and let me know in the comments what else you would like to see here on the channel. Thank you so much for watching, and I will see you next time.